see my face yet? Oh, hi there. Welcome back to my channel. We are going to be doing similar shapes. So by now you should have done all of the worksheets on congruence and you should have marked all of your work. This is where we are. We've done 2D shapes. That was super easy. That was when you're just matching shapes up on the grids, almost like a year 2 topic. We've done the proof. So now these letters should mean something to you now, and you should know what they are and how they represent congruence. What we're going to do now is focus on similarity and length. Yeah, let's get started. So you know that 2 shapes are congruent if they are the same shape and size, and 2 shapes are similar if they're the same shape but they are enlargements of each other. That's going to be your definition for similar shapes. So in this case, you can see the triangle is just bigger or smaller. Now, this doesn't just apply to triangles, it applies to any shape. So all circles and all squares are similar, no matter how you draw them, obviously if they have to actually be circles or squares. Other shapes like this, so you can see it doesn't really matter what they are. You again need to be told that they're similar, and with triangles there are some special cases as well where we're going to do some proofs. Now, what you may notice here is as the shapes get bigger and smaller, what happens to the angles? Well, you can see just immediately, I hope you can see immediately, the angles don't change. Those are all going to stay 90 degrees. That's going to stay 90 degrees. Those angles there will all match up. For the pentagon, they'll all be 108, I think, for each of the interior angles, and so on. So the angles do not change when the shape is enlarged. What happens to the lengths? Well, this is again harking back to year 9. We know that if a shape is enlarged by a certain scale factor, then it means the corresponding sides will also be enlarged by a scale factor. Let's just pretend that this triangle is twice as big as that in terms of length. But if that length was 4, this length would have to be 8 because the corresponding side is twice as big. And the same thing would happen here. If that length was 10, then that length would be 20. So there's 2 ways we can answer questions when we're looking for scale factors. The first way is to figure out the ratio within a shape. So in this case, there is a relationship between 5 and 8. What we can say is, if I divide the long length by the short length, or the other way around, I'm just going to do 8 over 5, then I will get the same answer as when I do 12 divided by, let's just call this x for now, because that ratio will be the same. I've realized actually it's better for me to flip the fractions. So I'm going to flip both of the fractions because I can do that. So it's just going to be 5 over 8 is equal to x over 12. I'm just going to rub that out. And then I can just work out what x is by multiplying both sides by 12. So 5 over 8 times 12. It's going to give me 7.5. So there's my 7.5. I knew that was the answer. I don't know why I worked that out. So that's method 1. Method 2 is where we can actually just figure out, okay, well, 8 times what will give me 12? Now, think about the double number line that we've done before in the past here. So 8, 12. I know some of you might be able to do this in your head, and that's fine. But if the numbers are not as nice, this method is going to be useful. So I divide by 8. I multiply by 12. So my scale factor is 12 over 8. And that means the same thing is going to apply here. 5 times 12 over 8 will give me 7.5. Now I can also do it the other way around. I can say I'm going that way, well, then I'm dividing by 12 and multiplying by 8. If I do 7.5 divided by 12 times 8, I will get an answer of 5. So there's two methods here. I have the answers on the other slide as well. It's just a bit neater. You can work out ratios in either case. Which of those methods you use is up to you. There's no rules on that. Have a go with these 4 questions. Again, these are not on the PDF, so pause the video and then I'll show the answers in a few seconds. You should be able to do the first 3 in your head. Okay, so hopefully you pause the video. You should have got the following answers. So 12, 32, and 25. And then for question 4, if you use a calculator, that's fine. 25.88 is what you should get. Now, similar shapes are the same shape but a different size, and they can be rotated or reflected. We already know that. Now, when it comes to triangles, there's special cases here. Do not copy this slide yet. I have another slide that's going to summarize everything. So 2 triangles are similar if they satisfy any one of the following conditions. So now we're going to move on to proving that triangles are similar to each other. So they're similar if all of the angles match. Now we've kind of discussed that with congruence. So if the triangles match, then yes, that triangle might be twice as big, but it's similar. It's the scale factor here. And there's an example just below with my face covering it. What you could also say is they're similar if all the sides on one triangle are scale factors of the corresponding sides of the other triangle. So you can again see here, if that's A, then that one must be 2A, and then so on for the other 2 sides. Another thing that needs to be true is 2 sides on one triangle are in the same ratio as the corresponding 2 sides on the other triangle, and the angle in between them is the same. So again, just an example here. So the angle has to match, and the 2 corresponding sides, which are enclosing that angle, have to have the same scale factor. So I've summarized it for you here. So this is what you're going to copy into your books, and you can pause the video. And I will also put this on a PDF in case you want to print it out. All angles in a triangle are the same. All sides on a triangle are in the same ratio as the corresponding sides, or you can say 2 sides are in the same ratio, and the angle in between. So this is in your PDF worksheets, but it's useful to copy this out just to embed it into your memory. So moving on to the next slide. It kind of relates back to the same style of questions with congruence, like, are these 2 triangles similar? Give a reason. Well, this one's really straightforward. We have 40, 50, 90, 40, 50, 90. Yes, they are similar. In this case, it matches reason 1. All angles on one triangle are same as all angles on the other. That's what you would write as an answer. Now, there is exercise 3 and 4 on similarity, which you're going to need to do. This is on Google Classroom. You should be checking your work. The answers are provided later on, especially exercise 4, because those are more exam style questions that you guys are going to be familiar with. This is just, again, to clarify where we are in terms of the week. This is the second topic, congruence, and we're a third of the way through it. So what's left is area and volume, and we'll be doing that in the next videos coming up.